Hey Chem Kids, Campbell here. In our second video on thermodynamics, we're going to talk about thermochemistry. So what is thermochemistry? Well, it's the study of energy changes that happen in a chemical reaction. Different types of energy can change in a chemical reaction. For example, heat, right? We can give heat off. The temperature gets hotter or cooler, like an endothermic or exothermic reaction. Remember that lab we did in first semester where the temperature went up in one reaction and it went down in another reaction? Well, those are changes in what's called enthalpy. And the types of energy we're going to study in this unit are enthalpy, which is symbolized by an H, entropy, which will be your next video, and Gibbs free energy, which we're going to talk about in class later in the week. Now, what is enthalpy? Like I said, it's symbolized by an H. I don't know why it's an H, but it's H. And it's the amount of heat absorbed or released in a reaction. So maybe that's why it's an H, because it's about the heat. So the amount of energy that's released in terms of heat in a chemical reaction. Now, exothermic reactions are reactions that release heat. And when they release heat, the temperature of the environment, the surroundings, goes up. So if you have a heating pad that is a chemical reaction, the temperature goes up, and that's why it makes your hands warm. But there's also endothermic reactions, reactions that absorb heat or get cooler. And what it means then is that because they're absorbing heat from the environment, the temperature of the environment goes down. And so the environment, the temperature will decrease if we're measuring the area around that reaction. And we actually saw that in that lab we did. So exothermic, temperature goes up because heat is released. Endothermic, temperature goes down because heat is absorbed. Now, we can calculate out how much heat is gained or lost in a reaction by doing what's called an enthalpy change, or a delta H. How we calculate that is we take the enthalpy difference between the reactions and the reactants and the products. And you're going to see in your on the back page of your homework packet is a table of H values, of enthalpy values. And what we're going to do is we're going to add up the products, and then we're going to add up the reactants, and we're going to take the sum of our products and we're going to subtract the sum of our reactants, and that'll tell us the delta H. Now, there are standard conditions for delta H, and they're not the same as STP, or standard temperature and pressure, when we did gases. Standard conditions for enthalpy changes is 1 atmospheric pressure, so that's the same. But the temperature is different. It's 25 degrees Celsius, which is about room temperature. Now let's talk about exothermic reactions. In an exothermic reaction, the reactant energy is higher. This is a graph of energy versus time. And our reactants have higher energy than our products. Now, you don't need to know much about this yet. That's the activation energy. And when we talk about kinetics and reaction rates, we'll talk more about that. But what you should know is that you should be able to look at this graph and say, oh, reactant energy is higher than product energy, so this must be an exothermic reaction. Because if the products have less energy, they have to give that heat out. So that excess energy is given off as heat, and then the temperature of the surroundings goes up. Now, sometimes we say in an exothermic reaction that heat is a product. And heat is a product because it's released in the reaction. So sometimes we can actually, like in our chemical equation, just put it as a product. Interesting. So exothermic reactions, the products have less energy than the reactants, and they give off heat because that energy's got to go somewhere. So, for example, if we look at the combustion of propane, propane is the gas that you use if you grill. And if I added up the enthalpies of carbon dioxide and water, I would get negative 2,147 kilojoules. And if I added up the H values, enthalpy values of propane and oxygen, I would get a value of negative 104 kilojoules. So from a negative standpoint, right, that's a bigger number. When I subtract them, products minus reactants, when you subtract a negative, remember it becomes a positive, I get a negative 2,043 kilojoules. Because this number is negative, it means that heat is released. So when you see a delta H value that's negative, Think exothermic reaction. I'm getting rid of heat. So burning of propane releases heat. Now that's good, right? Or we wouldn't be able to cook our steaks with it. An endothermic reaction is the opposite of that. Our reactants have lower energy than our products. So in order to get this reaction to happen, I've got to put energy into the reaction. So when the reactant energy is lower than the product energy, we have to put heat in so that heat gets absorbed, and when we take it out of the environment and put it into the reaction, that means the temperature goes down of the surroundings. So sometimes we say that heat is a reactant because we need it with the reactants in order to make the products occur. So exothermic reactions, reactants, products, heat is released. Endothermic reaction reactants, products, heat is absorbed. So let's take a look at this endothermic reaction. It's coal and water, produces carbon monoxide and hydrogen gas. If I add up the enthalpies of all the products, I get a negative 110.5 kilojoules. From a negative standpoint, that's a bigger number than my reactants, which is a negative 241.8 kilojoules. So when I go to do the math, products minus reactants, right, if I subtract a negative, remember I'm adding, and because that number is bigger, I end up with a positive 131.3 kilojoules. So when I have a delta H that's positive, that means it's an endothermic reaction and heat has to be absorbed. So plus delta H, endothermic, negative delta H, exothermic. All right, let's take a look at these mock reactions. I just made these up and I assigned them delta H values. Which of these reactions are exothermic? Well, if you said 1 and 4, you are correct because they're negative. And which of these reactions are, which of these are endothermic? Well, that would be 2 and 3, right? Which of these releases the most heat? That's what that says, most heat. Well, that would be number 4, right? Because it has the biggest value and it's negative, which means it releases heat. All right. In class, we're going to actually go through the steps of how do you calculate delta H values. So I'll see you in class.